Micro-ED made my research go on a faster rate, get to an answer quicker, and the answer could be that this material is useless for this application, but I didn't spend 4 or 5 months to get there. I could spend a couple of weeks to get there. My name is Omar Farha. I am a professor and the chairman of the chemistry department here at Northwestern University, also the chief scientific officer at Nomad Technologies. My team works on porous materials, and instead of going into the details, we call them smart programmable sponges. And we use these materials for a lot of applications, all the way from water harvesting, capture of CO2, all the way to detoxifying incredibly toxic chemicals.
We cover a large range of crystallographic techniques, that is both single crystal and powder-based, and not only with X-rays in these days, but also with electrons. So yeah, using a dedicated micro-ED is a huge gain on both the user side and also the management side. First of all, as a user, you don't have to worry about aligning lenses all the time when you switch from real space to a simple space. And essentially, being able to measure and analyze on the fly is also very ideal, something that is straightforward with X-ray crystallography, but nowadays also straightforward with ED.
Now we have one in our department, and I think the number of structures my team is getting is unbelievable. It's numbers that we didn't think we'll be able to collect in that amount of time that fast.
In my research, I'm aiming to create a family of heterometallic ordered MOFs where I have atomic level control over where the metals in my system are going.
So this is one of our 3 labs. In this lab, we primarily do synthesis. And in our other 2 labs, we do a lot of synthesis as well as characterization and radioactive material work, which has to be confined to its own area.
Micro-ED allows us to overcome a lot of the challenges when it comes to the size of the crystals that we're growing and the quality, as if sometimes maybe they're polycrystalline, or maybe we're making a batch that has a bunch of different morphologies in different phases from the same starting materials, but we can analyze all of those at once while doing micro-ED instead of individually picking crystals. So it was great that it became available early on in my PhD, so I was able to tailor a lot of my projects around it.
You can see I just took out some reactions where I grew some pretty nice single crystals here.
So I was using actually a design of experiments where I first could have performed over, close to 3,000 reactions. I was able to optimize that down to about 140 reactions. And then with those 140 reactions, beyond PXRD, I needed a better picture of what was actually going on in my samples that I couldn't achieve with just SEM because I didn't know what their structures were. All these different broken little crystallites, impurities. I needed to understand what all of the peaks were in my PXRD. So I could use micro-ED to take that TEM grid, look at the sample, look at the different components in my sample, and even if they have the same morphologies or different morphologies, analyze the structure of all of my components to understand what exactly was in there. Where if I tried to use X-ray diffractometry, I don't even think I would ever get diffraction for a lot of those pieces.
I was plating PXRD masks with some of my samples that I had totally washed and centrifuged down. So these are powder, and that begins the first step of the investigation to see exactly what we made. Kind of finding that fingerprint of our materials.
I think typically people spend many months, many hours trying to get crystal structures. You can go down and you can spend 8 hours picking crystals under a microscope all day and get nothing, no diffraction. And you could do that every day for a month, and you'll never know if you're actually going to solve a crystal structure or if you haven't picked the right crystal yet.
Since we had the micro-ED installed a little over a year and a half ago, I have definitely gravitated very strongly towards the micro-ED, structural characterization has always been a really strong and focal point of my research. And with the new capabilities that come with electron diffraction, definitely many people in the group have sought me out for help with structural determination. I have an actual personal story about one of my materials which undergoes an irreversible phase transition upon cooling, where the bulk, crystalline lattice fragments into a lot of different microcrystalline powder phases. And so traditionally, with single crystal X-ray diffraction, the story would have stopped there, would have been a dead end. But now with micro-ED, I was able to very easily identify this new crystalline phase and actually correctly identify the mechanism through which this phase transformation happens. It was basically micro-ED or bust.
These materials that, conventionally take between, 1 day to maybe 1 week to synthesize are very, very fast. So the turnaround here is very quick. And that's really great for, especially, being at Northwestern, having all of the in-house characterization facilities, because we can go from, starting a reaction, finishing the reaction within a day, and then heading down and immediately characterizing our samples. So the micro-ED definitely adds to that high throughput characterization process and pipeline.
I would say that not only is the strength of micro-ED the ability to take microcrystalline or polycrystalline phases and identify these, but actually to help us map entire synthetic landscapes where before we would basically get, a crystal structure that would agree well with our powder patterns and we would move on. But now being able to image so many different grains and so many different crystallites, we find sometimes even surprising minor products that really don't show up in the bulk characterization of powder pattern, for example. And so it's really allowed us to go beyond just problematic crystals, and solving those kind of challenging cases and actually really expand the scope of our structural characterization capabilities. I have no background in TEM or many other kinds of electron microscopy, so it was brand new to me. Definitely was a bit intimidated at first, with the entire TEM setup. It was something I wasn't really too familiar with. But that being said, it only took me, about 2 to 3 training sessions with our staff in-house to feel comfortable running the instrument on myself, and then only about a month or so to feel fully proficient in the use of the software and structure acquisition and everything that comes along with that.
I definitely entered my PhD as a very synthetic chemist. I came in with no crystallography experience, and crystallography is a very difficult, looming field. It's very challenging at times, and it's a very beautiful science. It's definitely an art, but for someone who's not trained in it, it's a very high barrier to entry. And I will say that the micro-ED, even with no TEM experience, makes it very easy to approach the field of crystallography because it's very user-friendly, it's very intuitive. You can look at the majority of your sample, you can see exactly what's going on, and you can literally click on each different crystallite, each different piece, and understand what all your components are with very little training compared to even how much you would need to do in order to use in TEM.
We want to be working on robotics. And a lot of times, robotic synthesis doesn't give you giant crystals. They give you more powders sub-micron because you want to be able to dispense them easily with pipettes. That's exactly the perfect size for micro-ED. And being able, I always say, making 96 reactions is easy. Characterizing 96 reactions is not. So I'm hoping that the micro-ED would be a main component in the characterization suite that we will be using for that technology. I think people all the way from a bio to pharma to material scientist and doesn't matter if it's a national lab, academia, or a company, they all can benefit from that. So if you're making co-crystals for pharma, guess what? You need the crystal structures to write that patent. And you might get there faster if you're using, smaller crystals. And yeah, if you want large crystals, you could get that later, but at least we'll tell you, did you make the right polymorph or you didn't? I think this is amazing, and what I'm hoping in the future, how can we be able to collect 40, 50 structures at a time and have a software that help us to analyze that data and give us all that data in minutes, instead of us sitting behind a computer for hours and days to analyze that many data. And I think that's what the future of my materials, that's what the future in pharma is. How can you get there faster?